Hello friends, today we are going to discuss on one of the interesting topic, that is the ultrasonic. We all know that the human ear can hear the sound waves of frequency lying in the range 20 Hz to the 20 kHz. This range is known as the audible range, and the sound waves of frequency greater than 20 kHz, that is the greater than audible range. These waves are known as the ultrasonic waves, and the sound waves of frequency, less than the 20 Hz are called the infrasonic waves. Infrasonic waves are used in a seismograph to record the features of the earthquake. The big animals like the whale, elephant, etc., they use the infrasonic waves to communicate each other. The ultrasonic waves have high frequency, that is, they have high energy, and that is why they have this small wavelength. So due to this property, that is the small wavelength, they have the high penetrating power, and that is why the ultrasonic waves have the number of applications in the various fields like marine engineering, aeronautics, industry, and in everyday life. We all know that nowadays the ultrasonic waves are used to detect the diseases in the human body. Similar to the sound waves, the ultrasonic waves also exhibit the phenomena like the reflection, refraction, diffraction, etc. The only difference is that these ultrasonic waves have high frequency and small wavelength. One of the very interesting example is that why the bats are easily fly in the night. In night, bat sends the ultrasonic waves, and suppose if there is an obstacle in their path, the ultrasonic waves gets reflected, bat gets an idea about the obstacle, and they change their path. That means by using the reflections of the ultrasonic waves, bats are easily fly in the night. Now see how the ultrasonic waves can be generated. Ultrasonic waves cannot be generated by the usual methods, because for the generation of ultrasonic waves, the source must vibrate at high frequency. For example, we cannot generate the ultrasonic waves by using the loudspeaker with electronic circuit, because at high frequency the inductive reactance of loudspeaker coil is very high, and so that no current will pass it, and at high frequency there may be the chances of breaking the diaphragms of the speaker, and that is why by using the usual methods ultrasonic waves cannot be generated. So there are two methods that can be used for the generation of ultrasonic waves. The number one is magnetostriction method, and second method is piezoelectric method. Now let's see what is magnetostriction. When the rod of ferromagnetic material like the iron, nickel, or the cobalt placed in steady strong magnetic field parallel to its length, then there is a very small change in length of rod. This phenomena is called the magnetostriction and was first discovered by the great scientist Joule in 1847. Now the change in length is not depending on the direction of magnetic field. It depends upon the intensity of magnetic field and the type of material which is used. The literature survey told us that suppose if we use iron, then length is increases, and suppose the nickel is used, length is decreases. Now the question automatically arises in our mind, why there is a change in length of that rod when the rod is placed in magnetic field. In ferromagnetic materials, we all know that in ferromagnetic materials domains are present, and when such a material placed in the magnetic field, then the domain structure gets displaced. So due to the displacement of domains, there is a change in the length of that rod. Now instead of this steady strong magnetic field, suppose the rod is placed in alternating magnetic field. That means suppose the rod is placed in a coil through which the alternating current will pass. Then in each half cycle of that alternating current, rod contract and expand. That is, the rod vibrate at a frequency twice the frequency of the applied magnetic field. Amplitude of the vibration is small, but when the resonance takes place, means when the frequency of the applied magnetic field, that is the frequency of AC, and the natural frequency of rod, that time the resonance takes place, amplitude of vibrations become larger and the rod vibrates strongly, and ultrasonic waves get produced at the ends of the rod. Now the natural frequency of rod is given by this relation. F is equal to 1 upon 2L root Y by rho, where L is length of that rod, Y is Young's modulus, and rho is density of the material of that rod. Now let's see how the ultrasonic waves gets generated with the help of electronic circuit. Okay. This is the electronic circuit of a magnetostriction oscillator. Hartley oscillator is used when the power supply is switched on. When the power supply is switched on, current starts through R1 and R2, which develop the voltage across the resistors R1 and R2 to keep the operating point of transistor in the active region, and so that in this circuit the transistor is used as an amplifier, and therefore the collector current starts increasing, and so that the voltage developed across the output of an amplifier. Now this output voltage is given to the coil L2, which charges in the form of magnetic field and then discharges through the capacitor C. Further, capacitor discharges through the coil L1, which develops the voltage at the input of an amplifier, that's transistor. So in this way the working is going on. The frequency of charging and discharging of inductor and capacitor depends on the values of L1, L2 and C, and the formula used for the frequency of the oscillations or the oscillator is 1 upon 2 pi root LC, where L is a resultant inductance of L1 and L2. If this frequency, means this F is equal to 1 upon 2 pi root LC, if this frequency, that is the frequency of this oscillator, matches with the natural frequency of rod, that is F is equal to 1 upon 2 pi root 1 upon 2L into root Y by rho, the resonance takes place and the rod vibrates with maximum amplitude, and ultrasonic waves are generated at the ends of the rod. By adjusting length of rod and the capacity of condenser or the resonance, the frequency as high as 300 MHz can be obtained. Generally, the nickel, iron, cobalt, they are used as the magnetostrictive materials, and generally the bundle of the wires of such materials are used to avoid the eddy current loss. The advantages of this oscillator is the magnetostrictive materials are easily available, electronic circuit is very simple to construct, and the large output power can be generated. Disadvantage is that the generation of frequency above 300 MHz is not possible, and when the single rod of ferromagnetic material is used, eddy current losses appear. Now let's see the second method, that is the piezoelectric method, but before this we must know what is piezoelectric effect. Piezo means pressure. The certain materials like the quartz, tourmaline, barium, titanate, etc., when they subjected to the pressure or tension, electric charges get developed on their opposite faces. This phenomena is called the piezoelectric effect. When the pressure or the tension is applied, electric charges develop on their opposite faces. Gas lighter is the best example for the piezoelectric effect. Now, why there is the development of charges when the pressure or the tension is applied? The piezoelectric crystals are the dielectric, and these crystals consist of the long molecular chain with unbalanced charges. When the pressure or the tension is applied, these charges create deficiency of electrons at one surface, that is positive charges, and the surplus of electrons at other surface, that is the negative charges. Now let's see how with the help of electronic circuit the ultrasonic waves can be generated. Okay. This circuit is similar to the magnetostriction oscillator. When this supply is switched on, then this oscillator start oscillating with the frequency given by the relation F is equal to 1 upon 2 pi root LC. By the transformer action, voltage also developed across this coil L3, which excite the crystal into the vibrations. And when the frequency of these vibrations, the frequency of this crystal, when becomes equal to the natural frequency, frequency of this crystal becomes equal to the frequency of this oscillator, then resonance takes place. This crystal vibrates strongly and ultrasonic wave generated at the ends of the crystal. The ultrasonic waves have the number of applications, but we have to consider only the few engineering applications, and they are, that is the detection of flaw in the material, ultrasonic drilling, ultrasonic welding, etc. Thank you.